This is just going to be. Hey guys?
This is when there's like
This is like a chain. This is a chain.
It's a chain, right?
Yeah.
okay.
Okay. This is why I want to do this one on the board before you guys get too heavy duty in the assignment, because this is one that if you do mess up, you're going to get messed up on the whole thing. Okay. Okay. So that's the left-hand side. Is everyone okay with the left-hand part? Michael, go ahead. The sign we're already taken care of. So the sign. That's
That was the first.
you guys, please. Okay. The sign changes the coast. Sine of 3x minus 2 changes the coast of 3x minus 2. So that's taken care of. The only thing left is then the derivative of 3x minus 2, which is just going to be 3. No, because these aren't, if you remember, Michael, this is just one expression, right? That's just one thing. Like, it's not sine times 3x minus 2. It's like sine of, like, all that is combined into one thing.
So it's just like that.
Yeah. Okay. All right, can someone be brave now? Okay, I know this is new stuff, guys, even though it's review, but I can't deal with all this whispering between every question. It's very difficult for me. I'm sorry. I know that makes me a lame teacher, according to those student. I gotta get over that. My wife says get over it. She gets yelled at every day. They don't even give me time to, because this is the class where they have to complain about everything. I'll say, here, everyone take $1. They'll go, I want 20. Right? Like, they, no matter what, I give them a Timbit, they go, how come we didn't get donuts? Like, it's ridiculous, that class. Anyway, enough with that. E to the 3x sine x. Can someone be brave and tell me how to do that one, please? Alistair, go. Excellent. Whoops. Let me write that down here. Plus 3x cosine. That's what you said, I hope, Alistair? Oh, that's what you said. 3x. No, it's just 3 sine x. Okay, so let's talk about. I'm sorry, I'm just driving me nuts today. I'm sorry. Okay, just I can't. Yeah, Michael, go ahead. Right. Good question. Okay. So why do I not include the ln for this one? Yeah, go ahead. Right, if the base of this is not e, so if it was like 3 to something, then you include the ln. Because if you type in your calculator ln of e, you just get an answer of 1. Right, so just mess up 1 and then 2. Yeah.
That's product rule base one.
Yeah, product rule base 1, that's all it was. So, yeah, go ahead.
So what is the ln representing?
ln, remember, is log base e.
We went over that yesterday.
Yeah, and before too, but that's okay. We reviewed it yesterday too. Okay. Yeah, go ahead.
I am also kind of still kind of confused.
Yeah, no problem.
So,
Well, this isn't yesterday yet, but go ahead.
yeah, but I meant like the ln.
Yeah.
So you use ln when e is not perfect?
Right, so if I were to do like 2 to the 4x, okay, if this is my function was this, dy over dx would equal ln 2 times 2 to the 4x times 4.
Okay.
Okay, if it's e, you just ignore the ln part. Now, are we done this question? Yes, we are, because I've known dy over dx, that's y prime. If you want to FOIL this out, you can do so. You can neaten it up if you want to. I might do that just because I'm a math teacher. So I'm going to call this 3 cos 3x minus 2 plus 3 sine x e to the 3x sine x plus 3x cos x times e to the 3x sine x. Either whatever is easier for you to deal with. Probably something like this. The question would say find the slope, or find the slope of x equals 1 or something like that. It would be the equation. So either whichever one's easier for you. Yes.
But do you not factor in 3?
Yes, you could. I'm not seeing anything. Let's slow down here. Yes, and that would be correct. Okay. The reason I'm not just so keen as I was before, because on the quotient rule and things like that, things cancel out. There's no hope of canceling out here, and it's not like you can solve a zero. Like if everything was a cos, 3x minus 2, I'd say yeah, because I can solve a root then, but it's difficult to find a root out of this. That's why I'm not eagerly jumping at it then. Okay. All right, are you ready for example 2? Now I'm going to lead you through example 2, the people that were here yesterday. It's for there's probably about, I'm going to say about 6 of you that weren't here yesterday, so you'll have no idea what's going to happen. I will talk you through it and we'll hopefully be good. Question? Yeah, this is warm-up B, I'm calling it. That's what I called it. Yeah, this is a warm-up, yeah. Warm-up B. I didn't finish this one. Now hold on here, let me write this down first. Okay. Now, this is a question here that we learned a fast way to do yesterday. Now, you could have done this using, Matt, you were here yesterday, right? Sorry you got bumped to the back. Thanks for being late, okay?
Yeah.
I apologize about that. Okay. But this is one that we did initially, you could use with quotient rule. Why is this one awful with you to use quotient rule for, though? Somebody tell me, Matt, I'm going to pick on you.
Yeah, just because it would take long.
It would take forever. You have a product in the numerators, if you do that separately, right? And then there's a quotient, so like it would take a whole page of work to do. Can someone that was here yesterday tell me the rule for the derivative of, so from yesterday, if y is equal to ln x, can somebody tell me what dy over dx equals? Because this is our last rule to get with. Yeah, Brennan, go ahead. 1 over x. Okay, so what's going to happen here? Here we go, guys. What's going to happen here is we're going to take the logarithm of everything, and what that's going to do is going to make our derivative of this very, very clean, very simple, very nice. Okay? Can someone that was here yesterday and only get to raise your hand once? Chris, by the way, the whole class, like, were you together? Like, it took 25 students to match up to you, just so you know. Your enthusiasm, your volunteering. The whole class that raised their hand once to match up. I was going to put down, that's an accomplishment. This is a good thing. I know you're down, so I'm sorry, okay, but it was a good thing that happened yesterday. Michael, what's the first step from yesterday, do you recall?
Yeah, isn't it 1 over like the original one?
Yeah, it's going to be, but you're, yeah, but,
Constant derivative.
yeah, well, let's just hold on a sec. That's exactly what it's going to be, but that's like the second step. You missed one whole thing first. Yeah? Yeah. So what we're going to do is you're going to take the ln of everything. And then we're going to use our power rules here in a sec. I'm going to change this to x plus 3 to the 1/2 if that's okay. Now you're probably saying to yourself, if you weren't here yesterday, Mr. Sadler, this is looking worse. Why the heaven would I do that? Let's let somebody use some power rules or some logarithm rules for me, please. What can I do with that big bracket using my log rules? Billy, go ahead. Yeah, so this is going to change into ln y equals ln 3x minus 2 to the 4 plus ln of x plus 1 cubed. I'll go to the next page. Minus ln, oh, bless you, whoever that was. Okay, I'm going to step back and let the power of this question sink in. Can someone explain to me how Bailey got that? What did Bailey actually do there? The ln, well, it's like our log rules, right? If you think back to last semester, right? To go backwards, when you add 2 logarithms, it's just a multiply, right? And when you subtract, it's divide, it's the same thing. Nathan, I'm going to pick on you, because you're sitting in the middle of the class. I don't like those exponents. For using my log rules, how do you deal with the exponents?
You could make it an over 1 and get rid of the line.
Yeah, not yet though. One thing first. Hold on a sec. I just don't like the 3x minus 2 to the 4. What do you do with that? Do you remember how to get rid of that 4? Teresa, go ahead.
I just got a question.
Yeah, go ahead.
I don't understand, like, why you do, like, plus.
Because that's one of the rules you learned from last year, logarithm rules. There's a logarithm rule that says like this. Does that one look familiar from last year? And that's all that I did there. Because remember, ln is really a logarithm. Okay, back to this. I heard some Matt raising a hand at the back. How do you do that exponent?
You just move it down, right?
Yeah. So this turns into ln y equals 4 ln 3x minus 2 plus 3 ln of x plus 1 minus 1/2 ln of x plus 3. Okay, so things are looking great, but not yet. We're going to recommend what Michael said to do. Okay? Michael, can you say what you said to do 3 steps ago? I'm just doing it now.
Was it, are you like 1 divided by the like original thing times the derivative?
Right on. So to take the derivative of ln y, it's going to change into 1 over y and then times your derivative of whatever the function is. Okay? So can someone be brave that was here yesterday? It's going to be Emma. Emma, can you be brave and... Okay, you can do it. If you take the derivative of ln 3x minus 2, forget the 4 for right now. What's the derivative of ln 3x minus 2? She's freezing. It's okay. I'll come back to you for the next one. I'll come back to you. Nate, go ahead.
It would be 1 over 3x minus 2
Yeah.
times 3.
Okay, now let me just slow down and make sure we're good at this before I continue. So what happened was, where did the 4 come from? Well, that was just there before, right? The derivative of ln 3x minus 2 is 1 over 3x minus 2, because whatever the function was, then times the derivative of the function. So the derivative of 3x minus 2 is just 3. All right? Luke, how are you feeling about this? No? Okay. Noah Solinger, can you be brave and try the next one for me?
It'd be 3 times 1 over x plus 1.
Right on. Okay. So the same thing happens, 1 over x plus 1, then the derivative of x plus 1 is just 1. All right. James, since you're trying not to make eye contact, I had a good computer question for you this morning. You weren't here though, so I had to ask Peter instead. What's the derivative of ln of x plus 3? What does that turn into?
This is just like 1/2 and then 1 over 3.
That's all it is, right? Now, if you have to think here, how much brain power went into those derivatives? A huge amount?
Yes.
Not a huge amount at all. If you remember how this question would have been, it would have been this big, the numerator. Right, Colin? You remember doing these on your tests and you remember you did f prime of x, g of x, and it was a big, huge headache? This is not intended to be a headache, okay? I'm still going to need this. Sorry, go ahead.
Are we gonna have to use like the original like quotient?
I will say use quotient rule to solve this, okay? I will tell you, I will label it out if I need you to, but... So I'm going to move this over here. Go ahead.
Why are we wearing that quotient?
Because here's the thing, these work the best for complicated things, but let's say I get you to do sine x over x, and I want you to find the derivative of that. Quotient rule is a lot more efficient to use. Okay, right? But for something that's horrible, this is so much faster on the horrible ones. Okay? Yeah.
Are we going to be, like on the example, we'll have to do like a plus h minus?
Yeah, only one of those questions.
Imagine doing this.
Yeah, I wouldn't do that. Okay, when I move the 1 over y over, what does it turn into? When I 1 divided by y, how do I move that over? 1 divided by y, so it's going to be y times 12 over 3x minus 2 plus 3 over x plus 1 minus 1 over 2x plus 6. And I want the equation of a tangent, if you remember. Right? Isn't that what it said? So I want the equation of the tangent at 1, 4. How do I find my slope now? Oh, nobody wants to pretend like they know. Yeah. So to find my slope, So this is going to turn into 4 times 12 over 1 plus 3 over 2, plus, sorry, minus 1 over 10, is that right? No, 1 over 8. So my slope is equal to, I can't actually do that in my head. I tried to make it work out nice, but it didn't quite work. 107 over 2? 107 over 2? Oh! Yuck. Now, if your calculator doesn't allow you to do it that quickly, you guys should be able to, if you guys are in calculus, to add 3 fractions and then times it by 4. Shouldn't be the end of the world. Okay? So to do y equals mx plus b to finish, 4 equals, oh boy, sorry about that. So I'm going to say b equals, oh boy, negative 99 over 2. Yuck. Therefore my equation is y equals 107 over 2 x minus 99 over 2. Can someone just confirm that for me? That was done without a calculator. Okay. Now, you may have noticed we did that yesterday, and we also did that today for Warmup. What does that probably tell you? Yeah, I probably, sorry, Callan, if you can't see, I'll scroll that up for it. It's probably going to be on your test, okay, because even if I didn't stress this on the assignment, I love these types of questions. Okay, it speeds it up, and this is when you're going to use in university for sure. If you got a big derivative, you'll just use your lawns and solve it quickly. Yes? No, because it's your x and your y, right? You know, if your slope, you do have to. It's like y, because that's just y times that. So my y value is 4, right? So 4 times whatever this was, which apparently is 107 over 2, apparently. Yeah, go ahead, James.
You have to leave it as fractions if you use.
Oh, James, divided by 2? Yes, leave it as a fraction. Divided by 2. Come on, it's divided by 2. It's not like I'm asking you to say, like, there's a button on your calculator that says change. I shouldn't have told you this, okay, but I'm doing it right now. Luke, isn't that what the button is? Change? It's change. I changed it to a fraction for you. If you don't have that calculator, you can ask to borrow Luke's because it says that. Okay, I want to, oh goodness, it's 9:30.